Hi everyone, my name is Robert Turnbull. I'm a Senior Research Data Specialist at the Melbourne Data Analytics Platform, or MDAP. At MDAP, we collaborate with researchers on data-intensive research problems. Our vision is that when you take modern data science techniques such as AI and combine them with the deep domain expertise from other academic disciplines, you can accelerate the discovery of knowledge and drive impact in society. Today I'm presenting Collectra. That's a tool we're building for building pipelines to extract information from collections. The goal is to make it much easier for researchers and institutions to turn images or documents into structured, searchable data. This is one of the work packages in the Enhanced Analytics project as part of the ARDC Community Data Lab. We've just started this project recently, so today I'm only going to explain what the software is going to do when it's complete, as well as talk through a few examples about how we're using it right now. But first I want to explain where the idea came from. In 2022, our team at MDAP worked on a collaboration with Jo Birch, who's the curator of the University of Melbourne's herbarium. Our herbarium has 170,000 specimen sheets, like this image on the right. It's a specimen collection collected by Joseph Banks in 1770. They typically have a label with information about the species, the date, the collector, the locality, and other fields. There are about 400 million specimen sheets held in over about 4,000 herbaria in the world. They're a treasure trove of biodiversity data, but the information on the labels needs to be digitized first. And at the current rate, that's going to take decades. That's why we created HESPI, a pipeline to take in images on a specimen sheet and run it through several AI models to extract information. First, it finds the components on the sheet. Then it focuses on the primary label and finds all the text fields. Then it uses AI to read the text in these fields and exports all this information to a spreadsheet as well as an HTML report. HESPI was quite successful. It was the cover story of the journal Bioscience in August this year, and there was an article about it in the conversation. And we're now working with herbaria around the world to be able to integrate this software into their workflows. Then earlier this year, we were approached by Museums Victoria to see if we could adapt HESPI to work on their collections. We tested HESPI on a graptolite fossil image, and it works surprisingly well. Graptolites are an ancient marine animal, much older than the dinosaurs. They existed all around the world from about 500 million years ago to about 320 million years ago. Their fossils not only give us biological information, but also tell us about the geology of that period in the planet's history. Museums Victoria have about 12,000 graptolite specimens that they need to digitize. Our plan was to create a new pipeline called Grapto to read these labels. But we didn't want to just create a one-off pipeline like HESPI. We wanted to also create a tool that would make it easy for anyone to create their own pipeline. That's why we're creating Collectra. It's a general pipeline builder to extract collection data. And we're very grateful to the ARDC to include this as a work package in the Enhanced Analytics project. Not only have they made the project happen, they're also giving us all the support we need in project management to make sure it's successful. Collectra can be the starting point for building any pipeline like HESPI or Grapto. Researchers and curators can take Collectra and build a pipeline from scratch, or they can take an existing Collectra pipeline and customize it for their own collection. Let me talk you through a few of the features. Firstly, Collectra is modular. Each task in the pipeline is like a Lego piece. Whether it's detecting objects, reading text, or classifying images, you can arrange the task however you wish. You can use a visual editor to connect all the blocks in your pipeline. You can also write the code yourself to implement a new kind of task that we haven't thought of. Secondly, Collectra works in bundles. We package the results of a pipeline run in a directory that's compatible with the Research Object Crate or RO Crate specification, and all the training data and the prediction results are in the identical format. That means that when you predict on an image, and once it's been manually verified, you can straight away use it to fine-tune the AI components with a couple of clicks. Collectra provides a graphical interface to allow you and your users to quickly edit and correct any predictions from the models and ensure that everything is correct. These corrected versions can then be exported to a database. We provide an easy way of fine-tuning the AI components. In the graphical user interface, after you've finished inspecting the predictions, you can choose the task you want to fine-tune and then click the train button, and the AI model will retrain based on the updated dataset. Finally, Collectra can automatically cluster your results and group similar items together. For example, in HESPI, we might want to cluster all the specimen labels to find out which ones have the same layout. You can just select the component that you want and click Cluster. The clusters appear visually, and you can explore them and select groups of them. Clustering also helps with annotation. Collectra uses the underlying embeddings to sort your data so that you see the most diverse samples first. This is a method called furthest first traversal. That way, if you correct or label the first 50 items, you've already covered most of the variation in your dataset. Let me show you some examples of the way we're using Collectra in a humanities context. The first is to explore the manuscript witnesses of Livy. Livy was a Roman historian writing during the time of Augustus. We are working with Andrew Turner and Julia Torello Hill to analyse the textual transmission of Livy. The textual evidence from the manuscripts of Livy have been collated into a print apparatus like you see on the right. We need to digitize an apparatus so that we know which variant readings each manuscript has. We use Collectra to build a pipeline that takes a scan of each page of the edition and identifies the footnotes and extracts the apparatus. It then uses a large language model to read the footnotes in markdown format, and then we use a large language model again to convert the output into the Text Encoding Initiative, or TEI. That has allowed us to come up with the family tree of the manuscripts of Livy. The second example is text and textvert. Over the last few decades, scholars have come up with hundreds of test locations in the New Testament and tried to look up every single Greek manuscript and see which variant readings are written. The results are printed in many very expensive volumes like this. This is an incredible data set, but it's currently locked away in printed form. So we used Collectra to first identify the components of each page and then separate each line and then get a large language model to read the text. Finally, there's a component to check the results to make sure that the numbers match up and no manuscript siglum is missing or duplicated. Now we can use that data for statistical analysis. The final example is a project to study the history of hourglasses with Matthew Champion. We've imported hundreds of images with an hourglass in them and annotated a bounding box around each one. We're now downloading tens of thousands of images from historical artwork from places on the web such as Google Arts and Culture, Gallica, and the Public Domain Image Archive, so that we can search for hourglasses across them all. Then Matthew Champion will be able to cluster these images and use those clusters as he writes a history of the representation of hourglasses. Well, that's all the time I have. We plan to release an alpha version of Collectra next year, and we hope that Collectra will help researchers unlock the hidden information in their collections, whether they're fossils, artwork, manuscripts, or anything else. If you're interested further, please see the Enhanced Analytics page on the ARDC website. You can also email us at mdap-info@unimelb.edu.au. Thanks very much.